Okay, let's get into the first conservative force, that is gravitation. So under gravitation, we have gravitational potential energy. So with this, we will understand a lot more about a conservative force. So potential energy is that energy which is generally stored, right? So it's a stored form of energy. So here the energy is stored, wherein in gravitational potential energy, the energy is stored because of the position. Because of the position above the surface of another object with mass. Remember, gravity is not only Earth's gravity is there, but everything that has mass has gravity. So make sense out of this statement. Official definition is gravitational potential energy is the energy an object possesses because of its position in a gravitational field. So we have a field. At different points, the gravitational field strength can be different. Again, there are quite a few variables that we'll be understanding. So is it a conservative or non-conservative force? It's a conservative force, right? And what is the formula? Formula is mgh. I hope you guys remember that. Then we have, just a second, I'm kind of lost. Yeah, then we have conservative nature of gravitational force. So this is where we'll understand the concept of conservative force a bit better. So the basic idea here is that we are trying to show that gravitational force work can be extracted completely and that it's independent of path. So we are doing two proofs. Okay. So let's dive into this. And I hope I'll make the conservative concept a lot clearer. So gravitational force as conservative force. Okay, first thing is we'll start off with, we know that potential energy of an object of mass m, the height h, above an object, above the surface. I think I'll go with above the surface, is given by u of h is equal to m into g into h. This you guys know. Now, if I differentiate this, with respect to h, what happens? You have du by dh is equal to m into g into 1. M and g are constant. dh by dh is 1. Right? And then you have du by dh is equal to minus f. See, this is nothing but f into a. Sorry, not f into a, m into a. M into a is nothing but your force. Force is, in this case, negative. Why is that? Say I am moving an object from point A to B, I am lifting it up. Right? There is work done by gravity, but in opposite direction. Is it not? Force of gravity is pointing downwards. And so the work done by gravity will be negative. Okay, because the gravitational force acts, or let me write this as gravitational force acts downward direction. Okay, so that would be your, no, let me take a step. F is equal to minus du h by dh. So this proves, okay, so this proves the conservative nature of gravitational force. Okay, that's that. Then we have, what else we have? Then we have the path independence. So for path independence, I'll take up a diagram. So for path independence, what we can do is we can take up the ground, and let me take up an object. Let me copy this. So the same object, I'll use it 3-4 times. So in case 1, I'm moving object from point A to point B. The same thing actually happens. Again, I need the same. I'll do the same thing, but in a different way. So these are 2 different cases, but it's the same consequence. Okay. So we have the object moving from point A to point B, right, in this path. So you can see that the height will obviously remain the same. But the difference here is, instead of going that way, right, whatever I just showed you guys, I'll go this way. So from point A to point B, from point A to point B. So this is straight up. In both the cases, we are reaching the same height h, but I'm going from point A to point, say, E, and then AB, okay, and D, and something like that. E to F, and F to D, and B, so on and so forth. So I'm taking different paths. So this is case 1, and that's case 2. Right? So now, so in this case, object is raised to a height of h. So we have case 1, object is raised to a height of h. So from A to B and perpendicular to the surface. Right? It's perpendicular to the, makes an angle of 90 degree. And this is, and is parallel to gravitational force. So we have work is equal to force times of displacement times of cos theta and stuff. And this is also equal to mgh. Right? Okay, the simple straightforward mgh. Now, case 2. This is where the proofs comes into picture. Object is raised to a height of h along the path. I have a weird path, A to E, I guess. AEFDB. AEFDB. Now, the work A to B can be written as work A to E plus the work that we do from E to F plus the work we do from F to D plus the work that we do from D to B. Now, work that we do from A to E, as you can see over here, is parallel to the gravity. So is parallel to the displacement, while E to F is perpendicular to displacement. Then we have F to A is again parallel, and then again it is perpendicular, right? Parallel, perpendicular to displacement, parallel to displacement, perpendicular to displacement. Remember, displacement is this line. Okay. If this is the case, then we have mg times of the parallel displacement will be A to E, the line segment AE, plus this is mg into 0, because there is no change in height. Okay. Then again mg into line segment, this will be F to D. I'll explain all of this again. Just let go through it. And perpendicular to it will be 0. There's no displacement. So then we have mg times of E line segment plus FD. So we have AE plus FD. AE plus FD will give us what? Will give us this entire length h. So we have this to be mgh. So we can see from 1 and 2, it is path independent. Therefore, from 1 and 2, it's path independent. That's it. Okay, guys. So let me explain what we just saw. This was supposed to be number 2. This is first, right? That was first. This is second. Path independent. Okay. So we are trying to prove with 2 things. See, guys, we have seen that conservative force, there are certain properties. I mean, we're not seen, but now we are seeing actually. So conservative force, they have negative gradient of potential change, and the other one is they are path independent. These are the 2 things that we are trying to see, right? Where did I show you guys that? Gravitational potential is energy possessed, that I did. Or we are trying to show that the gravitational force work can be exerted completely, and that is independent of path. So we are trying to show the conservative nature using 2 proofs actually. So one is the negative gradient, right? Force being negative gradient, this proves the conservative nature of gravitational force, this particular statement. And the other one is path independence. That's what we are trying to prove. All this comes from the point that conservative forces have all of this property. Where did we see that? Here. So how do we do it? So we are doing it by taking up the formula mgh. So mg, if I differentiate, I'll get mg. And this is the negative of the gravitational force. Because when we do certain work by increasing its height, the gravitational pull will have a negative, will be in the opposite direction. So the force will be negative. And so we got to see that force by gravity is negative gradient of change in potential energy. So this proves the conservative nature of gravity. That's one proof. Another proof is path independence. So we took 2 cases. One, we took the object up straight, and this leads to the point that the potential energy increased from 0 to mgh, right? We got the potential, the work done is mgh. While in case 2, we have the object moving from A to E, then E to F, then F to D, and D to B. Some A to E, we have positive work done, right, from our end. While EF, there's no change in height, so there's no change in potential energy, gravitational potential energy. From F to D, we have increase in potential energy. Then D to B, there's no change in potential energy. And so these values are zeros, right? H stands for change in potential energy, change in height. In these two cases, there's no change in height, and so end of it, we have this expression. So from 1 and 2, you can show that the path is independent. Okay, so those are your proofs. Yeah, you need to copy this. Okay, guys, I just want to make one thing clear. See, all of this is an extended version of all the things that you have learned. If you want to learn the basics, please always go back to 9th grade gravity chapter. End to end, you get to learn the basics, and then you can continue this part, because I don't want to re-record the same thing again and again. So it will not make sense. So fundamentals are always there for you guys to access. Please access that. And this is the advanced version of things. So if you are not able to grasp quite a few things which I'm telling over here, it's because your fundamentals are weak, and fundamentals are always that you guys are mature enough and you will be able to learn all of those. So post that, you come down here.